So I think this is like the final level of difficulty. Actually, what students actually find hard. Stuff in day 4 is going to get easier, the way we're going to talk about it. Now, we talked about this last day. When we have like brackets and fractions, we want to do the same thing and just get rid of the denominators by using the common denominator approach. But what is confusing can be is the way sometimes the number is represented. Like the procedure is the same, but the numbers the way they're presented can make it feel a lot more difficult, or something completely different is still the same. So for this question, I'll work with you guys. Before we do this, I want to get you guys to change this number here from a 2 to a 3, please. Okay? Change that to a 3 there. So now, when like the 3/4 out front is written like that, students often tend to make more mistakes. This 3/4 is multiplying this bracket, and this bracket here is actually part of the numerator. I find that students usually find it a little bit easier if we rewrite that bracket as a part of the numerator. So if you take this question and just rewrite it like this, it helps separate what's on the top, what's on the bottom. It makes it just a little bit easier for students not to make mistakes when we go further. Does that sort of make sense? Like this 3 is on the top, this 4 is on the bottom, the 4 is actually on the bottom of everything over here. So you just want to really show that. Right, so we go all the way across. Okay, so now, to make life a little bit harder, I gave you a mixed fraction. Just like in every single other situation in this year, if we given a mixed fraction, we convert it to an improper fraction. How do we do that? Jaden?
7
times 3, 21?
12 plus 1.
22. That's your numerator. So 22 over 3, and everything else remains the same. 3x minus 8 over 4. All right. So remember, our goal is to have x's by itself and all the numbers on the other side. That's isolating x. So we need to get x out of the bracket. We need to get the fractions gone. Right? First thing you're going to do is get rid of the fractions because it's part of the brackets here as well. What's our common denominator in this case? 12. So when we're multiplying, every term gets multiplied. This is one term. See, it's easier to see like that. This is one chunk. That's another chunk. So that gets multiplied by 12. And this gets multiplied by 12. Okay.
When did 8 get?
Sorry?
Never mind.
Okay. So now I'll start off with the right-hand side because that's a little bit easier to do because it doesn't have any x's in it. So remember, there's 2 ways to do this. You could multiply the tops. 22 times 12 divided by 3 is 88. Or the method I would like you to start working at is 3 fits into 12. 4 times 22 is 88, which is a much easier calculation to do in your head as well. Now, the next part is where students often have troubles, right? So remember, the goal is to get rid of the denominator. So each time we're just dividing the denominator with the number we multiplied, right? So 12 divided by 4 is 3, or 4 fits into 12 3 times. We're going to go like this. 4 fits into 12 3 times, or 12 divided by 4 is 3. Okay? And now we need to do the multiplication. Now, this is where a lot of mistakes happen, right? This 3 is multiplying the top just once, right? So we go 3 times 3 is 9. So we're going to multiply this and this. X minus 8. Right? Now, the mistake which I want to have you guys avoid is, which I see so often, is often, so don't write this part down, the people go 3 times 3, they'll do that 9. But then they will also go 3x, and they'll also go 24. They're so used to doing that. So that is wrong, because in our next step here is we're going to take the number outside and multiply it through. So if you do this, that 3 is already a part of this 9, right? So you don't want to double count it. So that's why you just multiply it to the number outside. Then when we do our second step of getting rid of the fraction, that's when we take that 3 that was originally on the outside, gets put to the inside, gets distributed. Is that okay? It's a lot of words, right? Right? So now we want to get rid of the brackets, right? So you go 9 multiplies x, which is 9x, and then multiplies the 8. What do we get? Where do we write down for that? Positive or negative? Negative, right? Because negative 8. Right? And it equals our 88. All right? So I've already changed the instructions on the board here. Step 1 kind of really depends on what the question looks like. It's either we get rid of the fractions and get rid of the brackets, sort of one in the same, depending on how the question sort of looks like. Now this becomes the easier part of it too. Okay? What do we do next? Which number do we move over? Jaden? Yeah, so we're going to add 72 here, add 72 here, those go away, 9x, right? So we got, what is that, 160? I'm not sure. I think that's 160 if I do it in my head. Yeah. All right, and then we want to get rid of the 9. How do we get rid of that 9? Jaden? Division. Just divide by 9. Here and here. Then x is equal to 160 over 9. And I don't think that can get any smaller, so we just leave it as is. Okay? Okay, so now I'm going to help you set up this one. Then I'm going to have you guys do it. I'll come around and I'll help you. So first step, convert this. All right, we got 2 times 2 is 4. Add the 1 is 5 over 2. Okay. Find the common denominator. Should be easy. The denominator is the same. Yeah. And try to simplify. Now, I'll come around and I'll help you. Make sure you're on the right track. The answer for this one is 24. If you get ahead of me and I don't come around to you. Okay, sorry about that. 23, answer's 19, and you guys got it all figured out, so I'm glad about that.
It was 24, not 23.
What? It was 19.
No, from what you said 23.
Yeah, oh, okay, yeah. It should be 19. I apologize. Okay, now I'm going to talk about word problems as well now. It won't be too long of a conversation, right? So, I'm supposed to teach you about word problems and all the different situations and setting up nice big equations for these word problems. But unfortunately, sometimes just common sense, it will take you a lot faster, a lot further than setting up a word equation. All right? So let's talk about the first one. The perimeter of a square is 49.2. The side length of the square is represented by this formula. Okay? It's asking what is x. So I'm going to draw this to help this out. All right? So we have a square, which means all the sides are the same length. Right? That's what the little line means. And they're saying, hey, the distance all the way around the perimeter is 49.2. And they're saying, hey, each side is x plus 4.1. X plus 4.1, x plus 4.1. Right? So if you were to set up an equation to solve this, it would have to be an equation involving perimeter, right? So how do we do perimeter? Well, perimeter is equal to adding up all the sides. This side plus this side plus this side plus this side, right? For adding up all the sides. But instead of doing, since all the sides are the same, instead of adding it 4 times, we could just say 4 times the sides, right? Does that make sense, right? Instead of adding 2 plus 2 plus 2 plus 2 4 times, you could just go 4 times 2, right? Now, if you want to set up the equation, it'd be like, okay, well, the perimeter all the way around is 49.2. And there's 4 of them, so that's what we're going to multiply, and each side is x plus 4.1. Right? So that's how big each side is, x plus 4.1. Now we have the equation just like we had on the first page, which you can multiply and get rid of the brackets and move the numbers around, right? Which is fine. And I want you to be able to do that. But I also want you to be able to critically think about these questions, and which makes solving them a little bit easier to do, right? If they give you the distance all the way around, and you know that all the sides are the same, how big is one side? What's the numerical value? How would you figure that out? All the way around is 49.2, and you have 4 sides, all the same. How big is each side? Sorry? Let's make it easier numbers.
49.2 divided by 4.
Yeah. Yeah, so we go 49.2 divided by 4, right? So each side is going to be that big, right? They're all equal size. So you take your calculator out, we go 49.2. 49.2 divided by 4, we got 12.3 centimeters each side, right? So we're trying to figure out what the x is. So we now have a lot easier thing to work with. We know that this distance across is 12.3. So we know that x plus 4.1 must be the same as 12.3. Do you see that? Right? Since this is how big this side is, and this side is also this expression, so these things are equal. Now we have a much easier thing to solve compared to this one, right? And easier to set up as well, right? So now we want to solve this, right? What's the next step?
Minus 4.
Yeah, just minus 4.1 here, minus 4.1 here. Those go away, and 12.3 minus 4.1, that is what, 8.2? Centimeters, yes, 8.2 centimeters. So x is 8.2 centimeters. Yeah. Now, if you prefer, you can do it this way, but I want you to just like kind of like sort of maybe necessarily ignore, not necessarily ignore what we're doing now, sort of combine the stuff you did in grade 8 and grade 7, because this is sort of what the approach you would have done in grade 8. Right? In grade 8, you don't have the x's, right? But you're, oh, they're all the same. I'm just going to divide by 4. Combine the knowledge from before with what we're doing now and make the equations easier for you to solve with. Right? Okay, so we're going to do one more before we start working on the assignment. Right? Another perimeter question. Right? So in grade 9, I said, hey, you don't have shapes, no formal unit on shapes. Right? You don't have a formal unit in shapes in grade 10 either. However, throughout the year, questions about perimeter, area, and volumes kind of show up in all these different chapters. That's what happened here in grade 9, and it'll happen here in grade 10 as well next year for you guys. Okay, so we have 2 equilateral triangles. Vocabulary. What is equilateral triangle?
Equal.
What's equal? All the sides are equal. So we have 2 of them, right? And it says they differ by 1.03. So we have 2 triangles, one's bigger, one's smaller. All right? So I'm going to draw, let's draw a large one just to help see what's going on. Right? All the sides are the same. Then we have a smaller one where it's also equilateral triangle and all of its sides are the same. So I'm going to use a double hash here. It's just so it's not indicating it's the same size as this one. They're all equal, but different from what here is. Okay? So the question is, and they say that the larger triangle, or right triangle, has a perimeter of 9.24. All the way around, 9.24 meters. And the question is, how big is a side on this triangle? You have a process here, Blake?
9.24 divided by 3
Okay.
minus
Okay, one step at a time. Let's do the 9.24 divided by 3. Let's calculate that number. 9.24 divided by 3. We get 3.08. And Blake, what does the 3.08 represent?
the length of the large
The-
side of the
Yeah,
large.
it tells you how big this is. 3.08. Okay. So next, what was your next step there?
It was minus 1.2.
All right. And why is it minus 1.03? Not add, not multiply, not divide.
Because the small triangle's that much smaller.
Yeah, this is differ means smaller. We're subtracting. So we're going to the smaller triangle and we're going to subtract this much size off of it. And you go 3.08 minus 1.03, so that's going to be 2.05. And the unit here are meters. Well, that's it. So we just word problem, we give a little sentence here. The side length of the small triangle is 2.05 meters. Now, I can show you how to set up an equation if you want. Do you want to see that? Or I think this approach makes much more sense, just following the logic in your mind, right? So I think we'll just leave it at that, and we'll spend about the next 40 minutes here just working on your assignment.